Now I am discussing about the increasing and decreasing, which is the second subtopic of chapter application of derivatives. Question raise, what is meaning by increasing, decreasing? What is meaning by strictly increasing and strictly decreasing? We can observe if we plot the graph of y is equals to x or y is equals to 2x plus 3. Then in some functions we find as and when we increase the value of x, the value of function continuously remain to increase. If it happens that if we increase the value of x, the value of fx or the value of y increases, we say the function is strictly increasing always. If it is a fact, it is a truth, then we say function is strictly increasing. But in case if I ask you to draw the graph of y is equals to minus x, fx is equals to minus x, as we increase the value of x, y or fx will automatically decrease. Or if I decrease the value of x, value of y will automatically increase. So in this situation, when reverse system follows, is known as the decreasing function. It is absolutely as same as we know in case of the direct and inverse variation in class 7th and 8th. In class 7th, we say that if both the quantities are varying with a constant rate, that is the direct proportion, and if one quantity increases, second decreases. As we increase the speed, the time for a particular destiny always reduced. If we decrease our speed, we find that the time always increase. But if we are going with more money to buy something, definitely you will purchase more amount. In that you will purchase more weight, more volume and more quantity, whatever you want to say. So increasing or decreasing is absolutely as per the direct and inverse variations, and its meaning is that if in a function the value of x or the value of independent variable we increase, then obviously and automatically we find that the value of independent variable increasing and the value of dependent is also increasing, and by decreasing it is also decreasing. It means what? It is the strictly increasing function. And reverse of it, that in a function always if when we increase the value of x, that is independent variable, value of y decreases, or if we increase the value of x, that is independent variable, value of y, that is dependent variable, decreases. If reverse happened, always that function is known as strictly decreasing. So after understanding the increasing and decreasing, strictly increasing and strictly decreasing, I would like to share with you one example, that is, so that fx equals to 2x minus 7 is strictly increasing function. We have here fx as 2x minus 7. In place of x, if I take a quantity, say x1, so fx1 become 2x1 minus 7, and we take f of x2, in place of x in the original equation we find 2x2 minus 7. We are finding that fx1 is this, fx2 is this, these are the two quantities, and in case if I assumes that the value of x1 is less than value of x2, if I assume it that x2 is more, x1 is less, then obviously if I multiply it by 2, I will find 2x1 is less than 2x2. If I subtract 7 from both sides, I will get 2x1 minus 7 is less than 2x2 minus 7. 2x1 minus 7 is fx1 and 2x2 minus 7 is fx2. So clearly here x2 is greater than x1 and we are finding fx2 is greater than fx1. So when we are increasing the value of x from x1 to x2, we are finding the value of function is also increasing, and it is in general, not in particular interval. So what we can say, this is the always increasing, and the function which is always increasing is known as strictly increasing function. So to test whether the function is strictly increasing or decreasing, we should test that if the value of x1 is less than x2, and in this condition if we are able to prove that fx1 is less than fx2, obviously we can say yes, it is strictly increasing. But if its reverse comes, we will say it is strictly decreasing. Now I am taking an example where I will let you know that how to prove that function is strictly decreasing. So that the function given by fx equals to minus of x, this function is strictly decreasing. Rule to show that function is strictly decreasing, that if x1 is greater than x2 and we find the value of fx1 is less than fx2, function is said to be strictly decreasing. To show its solution, I have assumed that let a value x1 is greater than x2. What will be the answer of fx1? It will be minus of x1 in this equation, and value of fx2 will be what? Minus of x2. Now I have taken x1 is greater than x2. What can I say? I can say minus of x1 is less than minus of x2, because if minus I put, then this inequality will get reversed. Minus of x1 is less than minus of x2, but in place of minus of x1, what we can put? fx1. So I can say fx1 is less than, in place of minus x2, I can say fx2. fx1 is coming less than fx2. What this shows? We were taking variable x1 was greater than variable x2, and with the help of this, what we have concluded, that value of fx1 is less than fx2, it become reversed. Hence we conclude that this function fx equals to minus x is always decreasing. That's why we use the word strictly decreasing, because there may be some functions where few part is increasing, other part is decreasing. So in that situation, we have not to say that it is strictly decreasing or strictly increasing. It depends. Few functions are strictly increasing, few are strictly decreasing, few are increasing and decreasing in the given particular interval. Now using the differentiation, I want to explain you how to say that the function is strictly increasing, strictly decreasing, or how to find in which interval is it increasing or decreasing. So that the fx equals to x cube minus 3x square plus 4x, where all x belonging to R is strictly increasing. As and when we want to prove that it is strictly increasing or decreasing, we will go to find its derivative f dash of x. First derivative of this is 3x square minus 6x plus 4. The first derivative, and if the value of first derivative comes positive, become positive, then function is always strictly increasing, and if that is negative, it is strictly decreasing. And if both, then in some interval some part of its domain is increasing and some part of domain it is decreasing. To check it, f dash of x is given by 3x square minus 6x plus 4. We can say this can be written as 3x square minus 6x plus 4. We can write it as 3 plus 1. This part we can take 3 as common and we obtain x square minus 2x plus 1 separate. This is coming out to be 3 times of this part. I can say it is x minus 1 whole square plus 1. You know I know, everyone knows that the whole square of the real numbers is always positive. This part is positive, or least value of it can be what? Its least value can be 0. 0 whole square is 0, otherwise its value will be more than 0. Multiplied by 3 is a positive or 0. When this positive number or 0 increased by 1, overall value comes as positive, as the first derivative of this function is coming positive, so we say it is strictly increasing. If it happens negative, we say it is strictly decreasing. Now I am discussing a problem where the function is completely neither increasing nor decreasing. Few part of the function is coming in the increasing zone and some part in the decreasing zone. How to identify, how to trace that interval, that is the purpose, aim to discuss this example. Find the interval in which the function f given by fx is equals to 4x cube minus 6x square minus 72x plus 30 is strictly increasing and strictly decreasing. If we talk about it, we find that fx is what? It is 4x cube minus 6x square minus 72x plus 30. Either for strictly increasing or for decreasing, we take f dash x, that is 12x minus, this is 12x square minus 12x minus 72 plus 0. This is the value of f dash x. Can also be written as 12 common x square minus 6x, then it is, we can say it is 12x, 12 is common, x square minus x minus 6. For increasing and decreasing intervals can be traced if we put f dash of x is 0. So with the help of this, when we put this part as 0, we will notice that x square minus x minus 6 is equals to 0, or x minus 3 into x plus 2 is equals to 0. X minus 3 into x plus 2 is equals to 0. By factorizing, we can say the critical points are minus 2 and plus 3. This is minus 2, this is plus 3. We take that sign after the highest value of the critical point, which sign bears the highest powered term in the function. Function is fx equals to 4x cube minus 6x square minus 72x plus 30. The degree is 3. Its sign is positive. So we will take positive sign here. Then after this critical point, we will change the sign minus, and after it sign will be of plus. So plus, minus and plus. Plus zone is for the increasing and minus zone is for decreasing. So for increasing, if we talk about, we are finding from minus infinity to minus 2, minus infinity to minus 2, and what? 3 to plus infinity. These two are the parts of the positive zone. So here in this much of the area, this much of the parts, the function will be considered increasing. And for decreasing, we select the negative zone. So far as decreasing is concerned, it will be minus 2 to 3. This is minus 2, this is 3. This is the part of the decreasing zone. Increasing zone, this is decreasing zone. How we have used? fx were given, differentiation is done, equated to 0, critical points are observed, points are put on the number line. Then we have obtained that the positive sign is of the maximum degree term. Then this positive is taken, immediate right to the highest value of the critical point, then changed plus, minus, plus, positive zone for increasing and the negative zone is for the decreasing. So this function is increasing from minus infinity to minus 2, minus infinity to minus 2. with union 3 to infinity and decreasing in the interval of -2 to 3 as indicated and solved and explained here.